Hello, and welcome to Backer Breaks It Down. In this episode, we're going to prove lines are parallel to each other, which means that they will never meet. Okay, so we prove that two lines are parallel to each other using these converse theorems. So you'll notice that we have 5 of these, and it's completely tied to those 5 angle pairs that are created when you cut parallel lines with a transversal. So corresponding angles, alternate interior, alternate exterior, same side interior, same side exterior. What you'll notice in all 5 of these postulates and theorems, it says, then the two lines are parallel. Okay, that's how it finishes. So if we can prove the if parts of these theorems, we can then conclude that the two lines are parallel. So we would need to prove that a pair of corresponding angles or alternate interior angles or alternate exterior angles are congruent, and then we can say the lines are parallel, or we can prove that a pair of same side interior angles or same side exterior angles are supplementary, and then we can say the lines are parallel. Okay, but before we get to actual formal proofs, let's just see if we can figure out which converse is being used. So in these 6 problems here, it says, can you prove that lines P and Q are parallel? If so, identify the theorem or postulate used. Okay, so what do we think about number 1? Yeah, this would be an example of the converse of the alternate exterior angle theorem, because the 2 angles that they give us are alternate exterior and they're congruent. Okay, so yeah, the 2 lines can be proven parallel. What about number 2? I agree, it doesn't go with any of our postulates or theorems. What about number 3? Yeah, those are vertical angles, and vertical angles alone will not prove parallel. How about number 4? Yeah, those are alternate interior angles and they're congruent to each other. So therefore, yes, P is parallel to Q. In 5, yeah, that would be the same side, the converse of the same side interior angles theorem, because 123 plus 57 does add up to be 180. And then finally, what about number 6? Yeah, number 6 is the converse of the corresponding angles postulate. Okay. All right, so let's bring some algebra into it and see if we can also prove that 2 lines are parallel to one another. So in this particular problem, it wants to know, is AB parallel to DC? Okay, and so where could we possibly start? Okay, I agree. We could totally start with triangle. It's not writing. There we go. Triangle BCD. Because they give us information about all 3 of those angles. And we know that all 3 of them should add to be 180 degrees. This will allow us to figure out what is x, right? So if I go 2x plus 3x, that's 6x. And then 6 plus 5 is 11, plus 19 is 30. So 6x plus 30 is 180. Right? And so we get that 6x is equal to 150, which means that x is equal to 25. So what do we now know? Okay, well, we know that angle BDC would be 44 degrees, right? We know that angle DBC would be, that'd be 56. Okay. Okay. And so there are 2 ways that we can determine parallel. I mean, using the angle measures thus far, we could be like, if you look at these like angles together, right? Because if AB is parallel to DC, then same side interior angles would be supplementary, right? So do those angles add up to be 180? So if we go 93 plus 43 plus 44, do we get 180? Yes, we do. So like one way that we can say that AB is parallel to DC is by using that converse of the same side interior angles theorem. Okay, that's one way, because there is another way. If you were thinking like, well, the measure of angle ABD would be 44 degrees using that triangle sum theorem, and thus these two angles are congruent. We could also say the lines are parallel by the converse of the alternate interior angles theorem. That would work as well, okay? But this is like the basics on like how we can prove two lines are parallel to one another. So it's just a matter of establishing like one of those 5 angle pair relationships. And if you can establish one of those or prove one of those, then you can say the two lines are parallel using the corresponding, like, well, I shouldn't say corresponding, but using the appropriate converse theorem or postulate, okay? That's how Backer breaks it down. Until next time.